we have 3 presentations this time. So that will go. Will come here later.
Oh, gotcha. Okay, yeah. And a lot of people, which is funny because the turnout's low.
Yeah.
Oh, there's Tiger. Yeah, she almost ran into me earlier.
Mhm.
Walked through the hallway turn. We nearly collapsed into each other. Ding! It's now 3:30. We're supposed to start this work. Pardon me? Yeah, please, could you? I would just ask for that. Minutes. The hardest question in the room. Minutes. This is when everyone looks down and pretends I'm not talking. I am your father. There we go. Thank you, Greg. So we need minutes, a minute taker before we move forward. We know people who are presenting is kind of tough if they do. So I know Human's presenting. Jeffrey is, oh, you have another Jeff. Awesome. So we're just looking for someone to take minutes. I saw your hand was up. That was interesting. You're not presenting though. So would you be willing to take notes for us or you have to take off? I knew it. It's always that. I'm double booked. I'm triple booked. I hear it all the time.
I think the incoming AD should take the notes.
Yeah, that's a great idea. That's the best way for him to really get on top, know the people, know the content. Oh, we got a thumbs up. Wow. I'll go a round of applause. That was great. All right. So we got minute taker. We got people coming in. I'm going to start moving forward. Where's go to next page. There it is. All right. Noting well, note. Thank you. Very important part. More noting. Where'd it go? How'd that disappear? Share slides. Status. Confirm. There it is. Okay. Oh, got it. It shifted that to, here it is. So even if you're in the room, get the light tool because it's used for hands up, hands down, for voting. It's kind of weird if it's on your phone. You don't need the video part. The light is just for participation and taking vote. And on the agenda, please take a look at it. Anything missing, shout, call us names. Right here. I think we have some people maybe coming in to present along the way. We've got a lot of double, triple books. So status, we've got a gross shortage of shepherds. It's always been the case. Finding people who can jump in and help shepherd these documents through. We've got a bunch that are kind of in the queue, in our queue, except not in the ISG, but we have 3 in the ISG, 1 in the editor's queue, and move forward. We've got drafts here that are looking for shepherds along the way. Like this. Look at the list.
Greg, can I just ask a quick question on that OSPF 3 draft? I believe that was meant to go to LSR for their approval, etc. Can you give any status update on that?
The LSR non-MPLS extension? This one here?
No, the OSPF V3 extensions. We were going to get LSR to take a look at that.
V3. Oh, yeah. This one here then.
Yes. Did that actually end up going to LSR? Did we get answers, etc.?
Early on, years ago. This stuff has been pretty big for a while, from what I understand. Anyone looking at it specifically, but from memory, right, the OSPF and ISIS work was kind of fundamental beginning of the BIER architecture because we required the attribute to be shared in the IGP. So that work began, and those groups, LSR group, was on top of this for a while. And I would assume at this point, if it's in the queue, it's gone through that process. I'd have to go check the mail and status to confirm, but knowing this stuff's been around for a while, I assume that's the case.
Yeah, no, I just remember that there was a request in one of the write-ups after the last call about checking whether or not this had gone to LSR. And I know we discussed it at the last meeting, but I didn't see any status update after that.
Yeah, I think it had to do with code points, didn't it, Jeffrey? Go ahead.
I think one of the co-authors is Peter, and he's in LSR.
Okay.
Yeah.
Perfect. Thank you. All right, that satisfy you, Andrew? Okay, fight. No, sorry, too early. All right, back to the list of shepherd requirements. You can see we got one review done, needs a shepherd. Shepherd review done, waiting for shepherd review, needs a shepherd, needs a shepherd. So we're looking for 3 shepherds in this list. BIER 6 just expired, just timing issues. We're going to rev it again and get it moved forward. It's an important part of our architecture. And so there will be requests for shepherds on that too. I know we don't have a lot of people in the room today. What's our head count? We have a hands up. Let's see. Can you hit that? Can I hit that? That was my hands up. Wow. Okay. I'm figuring this out. There we go. All right. First on the agenda. Let me get my next. I have to unshare this. Share again. LS extensions, BGP. Thank you.
Hello, everyone. I'm Zan from ZTE. Today, I would like to talk about BGP-RS extension for BIER. Next, please. This document specifies extensions to the BGP-RS address family in order to advertise BIER specific information. The following prefix attribute TRV are defined. The first is BIER information. The second one is BIER MPS encapsulation. And the third one is BIER non-MPS encapsulation. Next, please. The underlay drafts all passed working group last call, and as we think it is ready for the next step. Comments welcome. Thank you.
So, hey Stig. Yeah, this work's been around for a while as well. We're just kind of going through the process at this point. We've gone through last call. What was the status? Is it working? Looking for shepherd in this too? BGP
has done his work, and shepherd has done his work because but it may need the directories review.
Okay. So there's another review we're waiting on, or needs to be pushed through. Direct. Oh, okay. Yeah, we're waiting on them.
Right. Okay. Thank you.
Thank you very much. Okay.
Greg, if we can also just make sure that this draft goes via IDR as well. Tony's also said that the OSPF v3 extensions did not go to LSR. It went to IDR by accident, so it probably also still needs to go via LSR.
It went to IDR?
Yeah, apparently Tony just commented in the chat about it.
Fair enough. By assault, I'm looking at the text. I think it's a default. Instead, there was assault here.
We had the call in IDR working group, but it's no response from that working group. Yeah.
How do I get the chat?
I think the one went to IDR. Maybe it's the IDR extension draft. That one I know they went there. And we are actually having some discussion with Keaton, who reviewed the draft on behalf of IDR.
Yeah, apparently the OSPF draft got bundled with that by accident, and it should have gone to LSR but didn't. This link state draft also probably needs to go via IDR.
Okay. All right. Thank you. No.
Thanks.
All right. Next presentation, Sandy, I believe, right? Okay.
Hello, good afternoon, everyone. I'm Sandy Dong from ZTE. Today, this presentation is for BIER redundant ingress router failover issue. This draft has been presented in last meeting, and we received some comments about the relationship of the with the other drafts. So this is a clarification for this draft. I present the clarification on behalf of our co-author. Next, please. This is the brief introduction of this draft. This is an informational draft, and we discuss the scenario that the multicast source connects to ingress router. In BIER domain, it's BIER to avoid single node failure. And the three modes, such as cold, warm, and hot, are compared for BIER designed UMH selection. And the associated BIER specific methods for detection or switchover are discussed here, such as BIER ping and BIER BFD. Next, please. So this is a clarification with other drafts. This draft focuses on the environment that BIER is used is transport layer technology. And the BIER specific technologies can be used for candidate UMH failure detection. The overlay protection, such as duplicated sources, are not included in this draft. We know that in best working group, there is something drafts are talking about the duplicated sources protection in EVPN scenario, but we don't include this scenario here. And the draft in MBOD discusses the multicaster redundant ingress router failover issue in general perspectives, and it doesn't discuss the detail in BIER environment. The three modes for the ingress nodes are from RFC 1926, which defines MVPN extensions and the procedures that allow fast failover for upstream. MVPN is used as BIER overlay, we know, so it isn't covered by this draft too. This draft would like to bring some information for operator to select the suitable technologies in different BIER deployments. So, next. So this draft has been adopted after IETF 110, and the authors would like to ask for working group last call, and we welcome more review and comments. Thank you.
Who's read the draft? One in the room, two. Who thinks they're ready for last call? You can reserve. I think if it best, yeah, go ahead, Greg.
Sorry not to use the tool, Greg Mirsky, Ericsson. So as this document is using BFD for BIER, so it's probably would be good if progression some synchronized with their BIER OEM documents, including BIER BFD document.
Yeah, we discuss how to use BIER BFD in warm or cold.
Yes.
Or in these deployments.
Right.
Yeah.
Thank you.
Thank you.
Stig?
Yeah, hi. I haven't read the latest version. I'm not sure if you just updated it. So I would like to maybe read it again before I answer. But is it worth talking about, what's the name? The DF forwarder election? You know, we are starting to work on that. A DF forwarder, or
Yeah.
So I think, you know, that's at least that's relevant to this, I feel. So so a question I have is it worth kind of waiting a little bit with this so that can include details on the forwarder election, or should we just publish this as it is right now?
So that was a question to the group as a whole. I will give an answer as an individual contributor. I think this draft, as intended being informational, I think probably should wait till the election DF election changes actually move forward to a point where we can roll them into the draft. I mean, because otherwise it's just going to be a big hole.
Yeah. Yeah, I think it might be good to wait a little bit. It doesn't have to wait until it gets published, just until we kind of know
How
for
it
sure
works.
how it works.
Yeah.
Yeah.
Okay.
Okay. Thank you.
All right. Anyone else have opinion on that? I mean, I guess we take a temperature of the room. I didn't do it before with only one person, but I guess let's just do that for flavor. No, I'm not joining the queue. How do I do the, come on. Show of hands. Hey, there it is. All right. And this is redundant. Probably should get that spelling correct. Bam. All right. So the question ultimately is, as an informational draft, showing how what options are available for redundancy within a BIER domain. As Stig pointed out, DF election is that in PIM, by the way, Stig? No, it's here. It is here. But isn't there a general case as well?
Yes, Stig again. Yeah, so it's a good question. So at least the draft right now is for this working group. I mean, it's been presented only in this working group.
Okay.
And this is where we need it the most. But the way it's written, it's supposed to be a generic, solution that can be used anywhere, and potentially with PIM as well. So it's not quite clear which working group
what was the last you said?
It's not quite clear which working group it really should be done in, because it's kind of generic. BIER is the main use case, but yeah.
So just thinking out loud, being this primary use case, being the work really initiated here, I think it makes sense to continue, but PIM should probably review this before we move forward, which is having you in the room makes it happen. So thank you.
Sounds reasonable. Yeah.
Okay. So then the question I have is, do we wait a little bit on this redundancy draft until we have the mechanism complete for the DF election so we can roll that into this draft? Make sense of that? Can you, I'm just looking for some feedback. Show of hands on the app. Head count here is 23. All right, we got 7 yeses so far, no one objecting. Looks like all the votes we're going to get are voted. All right. Yeah, I think it's consensus, at least here in the room. We'll take it to the list as well, but really the draft authors are going to move forward, I think, with this direction. Thank you, everyone. Oh, we're up to 9. All right, I'm going to stop the count. We get the trajectory. Excellent. Thanks for the detail. Wow. I wanted to talk about little Greg. We'll get that next. All right. So next draft. Not show of hands. I got chat in. There we go. There it is. Yep. I saw the chat going around. It's like I had to get them going. Okay, so protection. Next is the Tofino implementation report. Do we have?
Yes.
We're going remote on this.
Yeah. Do you hear me? Okay. Can you hear me?
Yeah, we can hear you, and you can see the slides up. Just scream when you want them to change.
Yeah. Could I get control of the slides somehow?
I don't think that's possible. I'm presenting them here, so.
Okay,
I mean,
all right.
Well,
okay.
Can you present them? Do you have a copy of them?
I have, but I can also say just next slide. So that's fine.
Right. Just give me the boop and I'll change
that. Yeah, okay. Okay, thanks. My name is Steffen Lindner. I'm a postdoctoral researcher at the University of Tübingen. And today I'd like to talk about some updates on our P4 Tofino implementation experiences with advanced stateless multicast source routing. This is joint work with my colleague Michael Ment and Charles Eckert. Next slide, please. Okay, I'd like to start my talk with a short recap what we already presented at the last IETF. I also want to reiterate over our motivation and the concept for a solution. And then I'd like to talk about some updates on our mechanism, which we call segment encoded explicit trees, or short SEET. I will show an evaluation where we compare SEET with plain BIER, and then I'm going to conclude my talk. Next slide, please. Okay, what is the motivation for this talk as well as our talk at IETF 118? It is when we look at BIER bit strings that have typically a length of 256 bits, so 32 bytes, then these bit string lengths are not large enough to cover large networks. And therefore, when we have a large BIER domain, we partition that domain into multiple sets, where each set has at most 256 nodes, and then we use the set identifier to indicate the semantic of a bit string for that set, and this way we scale BIER to larger domains. However, when we have these large domains, we have many sets, and then we need a single packet copy per set that has a receiver in it, and this may lead to redundant packets on a link when this link is shared to reach different sets. We quantified this problem with the following experiment. We already presented similar results at the last IETF, but this time we have a small change in it. We look at the BIER domain with 1024 core nodes, and this time optimized set identifiers. So the last time the mapping between BIER and set was randomized. This time it is globally optimized on the BIER network. We have an average node degree of 4 at the core nodes, and then additionally 60 leaves connected to the core nodes, and different bit string lengths from 32 bytes to 256 bytes. We send from every source a BIER packet to n random receivers and average the results over 20 runs. And now we look at the relative additional packets that we need with BIER to reach all receivers compared to native IP multicast. That means when we have a value of 2, we need twice as many packets on all links in the network with BIER compared to IP multicast, which is the optimal solution. And what we can see here is that with small bit string sizes of 32 bytes, we have at most a factor of 1.8. This means that we need 1.8 as many packets with BIER to reach all destinations as with IP multicast. And of course, with larger bit string sizes, this factor decreases, but it's always larger than 1, so we are not optimal in that manner. Next slide, please. That's why we came up with a more generic way to do stateless multicast source routing, where the idea was the following. We have a multicast distribution tree, and we translate this distribution tree into a list of sequential instructions and encode these instructions in the packet header instead of using a flat BIER bit string. And when we do that, we don't need any sets or set identifiers as long as we have enough header space. And of course, if we have a limit on the header space, because forwarding ASICs can only process a certain number of bytes, then we need to split that header and send multiple packets as with BIER. And the forwarding principle here is the following. We have this encoded multicast tree, and then when we receive such a tree, for example, at node 2, we split the packet or the header into its subtrees. We have here a subtree for node 3 and node 4, and then we forward the subtree to its corresponding next hop. So node 3 receives a packet that has only the subtree of 3, and node 4 receives a packet that has only the subtree for node 4. So the packet shrinks along the forwarding path. Next slide, please. We implemented this generic concept with our mechanism, which we called segment encoded explicit trees, or short SEET. SEET uses domain-wide segment IDs to address a node, like in segment routing, and this concept is already included in draft Eckert PIM RTS forwarding. And the good thing with these global identifiers, with this global SIDs, is that we can address a remote node that is several hops away with a single segment. So when we have a longer path, we don't have to encode any hop with it. We can just address the remote node at the end of the path. Next slide, please. As a short example how seed worked, what we already presented at the last IETF is here an example. So we have a seed packet with a seed header that has several segments in it here on the left, segment 1 to segment 5. Each segment is composed of an identifier, a deliver bit, and a length field. The length field indicates how many bytes are part of this distribution tree after the segment. And the forwarding is now as follows. We receive such a packet. We'll look at the first identifier in the first segment. And if this identifier identifies the processing node, then we do something. Otherwise, we just forward the packet according to the identifier, for example, when we address a remote node. Then we check if the deliver bit is set. This means that we are a receiver of the distribution tree. If this is the case, we make a packet copy and pass it up the layers. And otherwise, we remove the first segment. And now we are in the middle figure here. And the following process is repeated until no segment is left. We look at the first segment that is now on the stack and look at the length field. Then we make a packet copy. We copy the first segment and the next L byte into that packet. This gives us the first packet on the right at the upper side. So we get a new packet which has the segments 2, 3, and 4, for example. Then we remove the first segment of the original packet as well as the next L byte. And then we repeat. We look at the next new first segment. In this case, it is segment 5. And we do the same. So we get from one seed packet, we get 2 seed packets where each packet has the corresponding subtree in its header as shown in the generic encoding example. This approach has a problem because we need for each receiver at least one segment so that we can indicate through the deliver bit that we want to give a packet copy to it. And a segment is 2 byte, 3 byte, 4 byte large, depending on the identifier. So it's rather inefficient to encode many receivers. Next slide. That's why we thought, what is the most efficient way to replicate a packet to many neighbors in an efficient way? And of course, the answer is BIER. That's why we introduced a new field in the header, the so-called bitstring indicator field, the B bit. And this bit indicates that a segment is not followed by other segments, but by a BIER bitstring, either a complete BIER header like an encapsulation, or a BIER-like bitstring with BIER semantic. Next slide, please. And with this approach, we can do the following. Assume we have a part of a distribution tree where we have a penultimate hop with ID 1052 that has 2 leaves connected to it, which are receivers of that tree, R1 and R3. And now we can do the following. Within our segment, we address the node 1052. The deliver bit is set to 0, and the bitstring indicator bit is set to 1, the B bit. And if the B bit is set, then we split the length field, which normally says how many bytes are part of the distribution tree, into 2 smaller fields, into the bitstring length, that indicates the length of the bitstring in bytes that follows that segment, and a set identifier that is used as in BIER with the same semantic. So, for example, the value 17 here is split into 2 values, the bitstring length with 1 byte, so we have a 1 byte bitstring that follows that segment, and the set identifier that says that this bitstring has the semantic of set 1. We get a bitstring afterwards, which is here now 5, and as in BIER, this bitstring says that the first and the third neighbor should receive a packet copy, and we can do the normal BIER logic here. So in this example, we are able to address 2 neighbors of that penultimate hop with a single byte instead of at least 2 segments, which would be at least 6 or 8 bytes. So we are really efficient here. And of course, if there would be more neighbors that need a packet copy, we could simply flip the bit. So what this does is basically we tunnel BIER over seed to a distribution node to a penultimate hop. And there we can do then the efficient replication via BIER. And the advantage with this approach is that we can combine the traffic engineering capabilities of seed. So we can traffic engineer our paths to the distribution nodes, to the edge of our distribution tree, and then do the efficient replication with BIER. And with this approach, we have less OAM overhead compared to BIER, and especially compared to BRTE, because in BRTE, we would need to assign the different links to different sets so that we can still do useful traffic engineering, and this whole problem doesn't exist with SEED. Next slide, please. We also evaluated this new approach with a similar experiment as in the motivation slide. So again, with a BIER domain with 1024 core nodes, with optimized BIER set identifiers, average node degree of 4. Each core node has 16 leaves, different bit string lengths from 32 bytes to 256 bytes, and again, every source sends a packet to n receivers averaged over 20 runs. And now we compare the number of packets that SEED requires to reach all receivers compared to BIER. And when we have here a BIER bit string length of 32 bytes, this also means that the SEED header is limited to 32 bytes in total when it's generated. So we have rather small SEED headers. And what we can see here is that when we have a small number of receivers between 4 and 2 to the power of 8, then we need less packets than BIER to reach all receivers. And if we have a large number of receivers, we are basically in the same order of magnitude as BIER with the number of receivers, but we still have the traffic engineering capabilities of SEED, which we don't have in BIER. We would need BRTE, and BRTE makes everything way complex and is also less efficient when we have a limited header size with BIER because we need the bits for the different links. Next slide, please. So as a conclusion, with SEED, we can encode a generic multicast tree, and we can combine it with either real BIER bit strings or with BIER-like bit strings, and thereby we get better scaling properties than BIER, and especially than BRTE in large networks, especially when the number of receivers is rather low. And we do not require subdomains or set identifiers, at least not globally. Of course, at the distribution nodes, we can do some kind of local set identifier to have multiple bit strings with different semantics, but we don't need a global conversion for that. SEED allows traffic engineering either hop by hop or on shortest paths, and again, it is implemented on P4 and Intel Tofino. It runs at line rate with 100 gigabit per second, and a paper with way more evaluations and implementation details is on the way. Thank you for your attention, and if there are any questions, I'm happy to answer them.
I have a question.
Yes.
What's the intention of the authors with this work? We brought it to the list before and they objected to adoption. So I'm just curious, what is your objective?
First, we of course like to hear feedback, whether this is a real problem within BIER that we have these redundant packet copies in large networks with small bit string lengths.
Excuse me, but that you're talking about what the intention of the solution is. I'm talking about the work itself in terms of like having a draft that we can work on publicly. We were asked about decoupling, we had to do an encoding, but the encoding request in this group was rejected. So we have people interested, we have people with ideas to collaborate, and the intent of a working group is that collaborating on written documents. So I'm fascinated by this work. I think what you're doing is great. I like these presentations, but I would like it in the context we have work to discuss and collaborate on. So the question still stands. What's your intention with this, the work itself in the IETF?
If the working group thinks that this still fits the agenda, then we'd like to do that, continue that as draft. Because originally we also had these RBS ideas in it, and now RBS is more like excluded here, so we're focusing on the BIER bit string. And if this really fits the working group purpose, then we are happy to continue that as working group document.
I think I caught most of that. Interesting. Tony's got a comment too by IPR. All right, so I guess until you've got something to point at, we can't really have a vote in terms of on a draft. If you have a draft you want to resubmit, we're here. We want to collaborate. We like the ideas. We like, the people have ideas to actually, potentially some corner cases resolved with different encoding solutions. But we need to have a public discussion. Otherwise, it really kind of sits orthogonal working group and we're just, showing your science projects. I mean, don't take that personal. I like what you're doing, like I said, but in the context of the IETF, we're supposed to work together on something. So get a doc out there, take it to the group, and then we can vote and see where we stand.
All right. Okay. Thanks.
Thank you. Anyone else with questions, comments? Okay. Next, show of hands, stop that. It's down here. Share slides, okay. ENTC is a great one. All right, Homan.
All right, so Berlin, when was that? In February. Next slide, please. So we got all together on the second week of ENTC, and we tried to bring up BIER between Nokia, Juniper, Huawei, and actually there was IEXIA testers in there too. And the outcome was very great. If you can go to the next slide, please. Thank you. Next one too. So from very high level point of view, what we accomplished was that we were able to signal BIER forwarding information or routing information via ISIS, IPv4 only. We demonstrated that sending BIER packets with the BIER header, which had 256 bit of BIER header, all the routers and all the parties were capable of replicating and forwarding all this traffic from one end to the other end. One thing was that the routers that we were using, the Juniper, Nokia, Huawei, we were all acting as transit router, BFR routers, and IEXIA was pumping the traffic with the different BIER bed index in the BIER header, so we can replicate it accordingly to the test plan from one end to the other end. And we only had 3 days of doing this. The first day was just coming up with the network, trying to figure out how to connect this stuff. I mean, if you guys have been to ENTC, EANTC, you know what a mess that is over there. You need to figure out the different SFPs, you need to bring up the ports. So the first stage just goes for bringing up all these different routers, connectivity, et cetera, which I thought it went pretty smoothly. And the second day and the third day, we brought up the BIER. Again, there was no hiccup. This is why there were 2 other test cases that we wanted to accomplish, but we couldn't do it just because of the time. And one of those was ECMP, just to show that we can have redundancy and resiliency for BIER through multiple ECMP links. Again, I don't think it was a failure. We just didn't have the time to set it up correctly and bring it up. And the overlay where the IEXIA pumps in just pure multicast, and we have a next generation MVPN with BIER PIMZ to forward it. Again, we didn't have time to accomplish that, so those are going to be next year. Next slide, please. So here's the network that we put together. All the links, if I remember correctly, there were 400 gig and 100 gig. So these were some fat pipes that we were connecting together. As you can see, the IX network was connected to the Nokias, to the Juniper, and to the Huawei. And as I mentioned previously, it was just sending out the random BIER bit in bit index in the header. So, we were replicating it based on that. Next slide, please. I think I went through this. Maybe next slide. Yeah, so what we kind of accomplished was that we were able to send the BFR IDs from IEXIA on all the routers, build the routing table, the BIER routing table, build the forwarding table. Again, all this was done via ISIS IPv4. perhaps later on, if there is development in OSPF or something like that, we can actually try that too. I'm just trying to go through some of these points. And obviously, as I said, again, IXCR, the tester, was pumping the traffic at line rate, and everybody was behaving. So, I mean, I wish there was something more exciting to say here, but I mean, it just came up the first time and it started working, which kind of, shows how simple is the protocol, how seamlessly it works with the IGP, all those TLVs, and, how every single vendor has done a great job implementing it. Because, again, as much as I love to say there was a bug, that we couldn't find anything, at least from forwarding point of view. Next slide, please. Yeah, so what is left is that I think next year we definitely want to try the NGM VPN overlay to make sure that at least when it comes to BIER and different type of application, we do have an end-to-end interrupt between multiple vendors just to pump in simple traffic, and then we can transport it over NGM VPN with the BIER PIMSy. And we're gonna demo what we did in EANTC in the MPLS Congress 2024, just for I guess the whole world to see that this piece is working. That's all I got, guys.
All right. Good job.
I think great stuff. Having spent 9 years at the INTC, I know the pain. 2 questions. So the data plan is in PLS, right?
Yes, it was MPLS.
And are you aware that seen BGP implementations?
Sorry?
The BGP implementation for BIER.
So again, all we tested was ISIS.
No, outside of what you tested in general, is there any work on BGP besides ATF? I mean, are there implementations?
In Nokia, we are not. I don't know. Are you guys doing anything in Juniper? I have no idea. No.
Okay, thank you.
Yeah, sorry.
Good, Stig.
Yeah, Stig here. Maybe I missed it, but did you test with traffic, or did it just bring up the routing and see that?
No, there was 400 gig of traffic we pumped.
Right. And what was the bit set size? The 256?
It was 256 for all vendors,
yeah.
Including the. So when I say, just to be sure, when I say IXCR or IX network, that's the tester, right? So the tester that we have in most of our labs that pumps in the traffic. So IX network was actually pumping in, I think it was UDP packets with the BIER header on top of it.
Oh, okay.
Yeah.
Okay.
Yeah, and I was surprised they were pumping 400 gigs. So I was like, hats off.
All right, we have another hand at the mic.
Hi, this is Xu Song from Huawei. Thank you, Human, to sharing the interoperations. And as far as I know, there is also some test about the IPv6 extension header-based BIER forwarding. Actually, again, I think I don't know whether it's a good opportunity to ask if people in the working group also interested in this kind of interoperations or deployment status. Also, I'm sorry I missed the previous discussions in the working group. In the beginning of the working group, I noticed there is some chat in the chat box or some communication between responsible AD and Tony. So I'm wondering whether it is also related. Sorry, maybe the question is for the chair, not for you, Human. Sorry.
Yeah, I mean, I wasn't part of the IPv6. I don't know, were you guys, Juniper? I wasn't aware of the IPv6 part of it. I'm not sure.
It's just between Huawei and H3C, two vendors.
Oh, okay.
Yeah, it's IPv6 extension header based. So maybe the question is not for you, it's for
Sure.
working group or working group chair.
I'm trying to get the sense of this. You're saying there's a different test you're trying to get implemented. I'm having trouble following. What's the point?
Yes, actually, just I think at the same time of the INTEC test that Human has already introduced, there is another INTEC test about the IPv6 based BIER forwarding. Yeah.
Gotcha, but that's not the work for this group.
Sorry.
Is that work represented in this group?
Yes, it has been presented previously, but
Well, but yeah, right, but it has
Yeah.
not been adopted here, has it?
yes, yes. So I'm just wondering whether people are also interested in this type of discussion.
We take the list as a request for presentation.
Okay,
And we'll see if
sure,
we get it from there.
sure, sure.
But, you know, we're trying to focus on what we've adopted.
Yeah, understood. Also, noticed there is some discussions in the chat box about IPv6 and RFC 8200. Is it also
Yeah, this-
related to the?
That's,
to this?
I think that's kind of inappropriate for this discussion at the moment.
Uh-huh.
You know, we're focusing on this presentation.
Okay.
He's
sure,
talking about this work and this test.
Sure.
Let's stay
okay.
focused. All right?
Okay.
Thank
sure,
you.
Understood. Thank you.
All right. Any more questions about this? I got some feedback, if you don't mind. So this is great. This is actual hardware.
Yeah.
Whereas at the hackathon, I guess, was it in Prague or before then? We had software implementations that were tested, correct?
I mean, again, Juniper had, I let Jeffrey talk about Juniper. On the IETF, last IETF, Nokia had the hardware. Juniper had the software, but this one all was hardware.
Fantastic. All right.
Yeah, Jeffrey from Juniper. Just a clarification for the last testing in IETF 118. We used a software-based simulation, but it was software simulation simulating hardware. So it was really like hardware based. But what was tested as part of ENTC is the same software we tested.
Excellent. Thank you, Jeffrey.
Yeah, just to complete on that. So on the MPLS Congress 2024, it's just going to be all hardware too. I mean, this is live hardware working, pumping the 400 gigs.
There's the same vendors, or are we getting anyone new involved?
From what I know, it's going to be the same vendors.
All right. But it's open to anybody, isn't it?
The more the merrier. Bring it on. Definitely, we're going to try to, now that we have to this, we have arrived to this point. I think next year we try to take it, you know, a step farther. So anybody, any vendor wants to join us, yeah, the more the merrier.
Excellent. Thank you very much. Great work.
Thank you.
Okay, next in the queue. BIER Anycast label. Is yeah, they here?
Yep.
See you.
Are you here in the room? Remote.
Oh,
Okay.
there we go. We see him. Yeah, we can't hear you. Let's see if we got you muted. Where is she? No, you shouldn't be muted. You muted on your side? No, we still can't hear you. I don't know what to do. I mean, we're like audio, video published. There she tried again. I can see her resetting it on her end as we get the status change, but we still don't hear.
We can see you, but we can't hear you.
Can't.
Maybe you can close the medical and enter again. Yeah.
Waiting for her to come back. go. You have audio permission. And she's not coming up with video either now. Yeah, no.
No, so we can't hear you.
Is there anyone in the room that can present this? We're not getting audio from the remote connector at all. They've disconnected and reconnected a couple times and we're not even seeing her now, but we see the audio connection, given permission, all in green, but we can't hear. Can you?
Maybe we can go on to the next topic and I will try to connect my colleague.
Oh,
to
okay,
try to
sure.
help. Yeah.
All right. Suggestion was to go on to the next presentation. She's going to try to get the connection working and we can come back to it. Excellent. Thank you. All right. So, she there? No. All right. Moving on. Last prezo, in-cap for OAM. Excellent.
Hello, everyone. It's Xiaoming from ZTE. This presentation is on BIER encapsulation for IOM data. Next slide, please. This chapter provides the encapsulation for IOM over BIER. Actually, we have three options to encapsulate IOM in BIER. Option one is BIER header plus BIER OAM header and plus IOM header and plus payload. Option two is BIER header plus IOM header plus payload. Option three is BIER header plus IOM as BIER extension header and plus payload. This draft selects option three as the standardized one to encapsulate IOM over BIER. And please note that the BIER extension header is defined in another draft, Zizang BIER extension headers. And that draft is still an individual draft. Next slide, please. Here is the published IOM options and encapsulations documents. I've seen 91, 97 data fields for IOM. This RFC defines IOM trace option, IOM proof of transit option, and IOM edge-to-edge option. RFC 9326, IOM direct exporting. This RFC defines IOM DEX option. RFC 9452, NSH encapsulation for IOM data. This RFC defines IOM over NSH encapsulation. RFC 9486, IPv6 options for IOM. This RFC defines IOM over IPv6 encapsulation. Next slide, please. It's deemed necessary to carry IOM data in BIER. Some multicast flows, such as live video and real-time meeting, are sensitive to packet loss, delay, and other factors. And IOM provides a way to achieve unpassed telemetry information collection, which is necessary for the BIER network operators. Next slide, please. This slide illustrates the IOM over BIER encapsulation selected by this draft. On the left side, it's the BIER header plus BIER extension header plus upper layer headers or payload. This format is defined in draft JSON BIER extension header. And the BIER extension header is composed of extension top header and one or more extension headers. On the upper right, there is a format for the extension top header. This format is also defined in draft JSON BIER extension header. And on the lower right row, there is a format for the IAM option as a BIER extension header. It shows how an IAM option can be encapsulated into a BIER. And this is a future-proof encapsulation for IAM over BIER. For each IAM option, it can be treated as a BIER extension header, and multiple IAM options can be encapsulated as multiple BIER extension headers. And IAM options and other BIER extension headers, which may be defined in separate drafts in the future, can be skipped once for all. That's due to the existence of the extension top header. So it's very flexible encapsulation. Next slide, please. Next steps, they also first ask for a working group adoption of draft JSON BIER extension headers. And we'll also revise this draft BIER IOM to apply the encapsulation I just presented. And after that, we'll ask for working group adoption of this draft BIER IOM. That's all. Thank you.
Would stay there for a second. This is interesting. I mean, there's dependency here, which is understandable, but we're not presenting that document. This is already out there. So in order to move this forward, we have to adopt that draft. And we haven't actually taken that. We haven't had it presented here to even take a vote, but honestly, vote goes to the list anyway. Point, Jeffrey?
So the BIER extension drafts was presented before, and there's no change here. That's why we didn't ask to present it this time.
Okay,
Yeah.
fair enough. So we've already there. Who's read the extensions draft? Been a bit. I mean, I'd have to reread it myself, but I do remember reading it. We got two. All right. Who thinks it's ready for adoption? I mean, use case here, sure. All right, we get two. I mean, it's not a big vote to go. We're not presenting it here. However, this work is dependent. So we'll take it to the list. We'll bring that stuff forward as well and take the full vote at the list and move on. But stick around because Greg and I ran into each other in the hallway earlier and brought up something interesting that's actually IETF wide, but it's specifically to OAM right now. And that is before this work really began, or I said beginning of this work, there was a requirements draft. And it's kind of been my experience in the IETF that we write problem statements, we write requirements draft, and they're used to develop the solutions, but then they're never published and they fall off and become basically archived and you got to dig them up. And so we fail as a group to publish our history, right? To document it in a way that's easy to find without going back and looking for expired drafts. So the question Greg had is like, should we take this requirements draft forward and publish it as informational? And there may be some resistance about that, but just taking the BIER example, I believe I wrote the problem statement originally for the BIER working group. And in that was a robust narrative about why we are where we are. And I thought it'd be a nice piece of history to go forward. And at the time, there was no interest. The ADs even chuckled at the idea of publishing a problem statements draft. And here we are now in M1D trying to document all the reasons why we are where we are. And suddenly that draft narrative makes a lot of sense and needs to go in there. It's like, if it was already published, we could have just pointed to it and moved on. So I think my own personal learning through the process, I think it would be helpful if we were to publish requirements drafts, problem statements. And as a working group, I would like to begin doing that so we can at least set an example, document our history in a way that's easy to trace. There was a lot of BS slinging around. Anyone had a chance to think about that? Some immediate thoughts from the chair would be fine. I think some AD feedback would be great because, like I said, the AD feedback I got in the past was, okay, the work is what we move forward and not the process, and that may have changed. Andrew, Gunter, thoughts, feelings?
There's been a bit of discussion within the IESG about publishing use case drafts, etc., etc. Some of the time, it requires justification of why you're doing it. That needs to be clearly stated that we're publishing this for these reasons. They may tell you to create the draft, but never publish it as well. So I think that it's probably a discussion you should have with Gunter as the incoming AD, see how he wants to take it forward. Personally, I think that use case drafts can be fairly useful at times. Whether or not they are published, they're still worth having in the record.
Yeah. It just, my experience is if they don't get published, they kind of vanish into the archive, and it's not an obvious way to find them unless you're specifically looking for them.
Yeah, I mean, that's a discussion worth having, I think, with Gunter. And Gunter, I don't know if you want to comment, but I think that probably might need a bit more discussion on the IESG based on, the past history with drafts like that and, some debate about whether or not they should be published.
Yeah, so during the time of the ISG discussions, I wasn't really part of the team just yet, but looking from my own experience, as a chair myself in working groups, I think actually having history documented in use case documents and the reasons why we do things is actually very relevant, because it will actually help you tune technology, going forward and keep track of developing the right things, because otherwise it's very easy to get off track, doing spending a lot of energy and time in very niche solutions which nobody will really will really use. And the other benefit of these use case documents is it often triggers another audience to look into these documents, because this is more tailored towards people using these technologies, and that is not necessarily what people implementing these technologies are trying to do. It really gives a focus upon on the reason why we have these things and what sort of KPIs they want to see, for example. So I think it is definitely useful.
Excellent. Thank you, Gunter. Thank you too, Andrew. Any other comments on that process? Wait, Jeffrey?
So Jeffrey from Juniper. My impression is that in IETF, once the document is published, is posted, whether it's individual or working group drafts, it's really hard for you to lose it. It's always there. Even the expired drafts, you can still find it. That's one impression. Another one is that it seems that before the big ticket items starts, for example, a working group starts, it's natural to require the use case and problem statements, and those are definitely required. And then for some very controversial issues where people will debate whether we need this or not, in those situations, it's also important to have those documents, requirement documents. Other than that, for some straightforward issue, hello? For some straightforward, simple or simpler problems, the requirement the drafts, do we really need it? I guess there are a lot of examples where we did not require those, and we just go ahead. And then in this particular case, the IOM encapsulate those information in the various extension headers. For example, in IPv6 extension headers, I suppose we have already done a lot of work for the other encapsulations. And we are just merely extend that concept to BIER in this case. So we probably do not need a requirements draft for this either, just some thoughts.
Okay, so just speaking from my tail from what I heard you say, yeah, I agree with a lot of the process where the documents just go. And I think you're right. You can find them if you know what you're looking for. But list of RFCs in a working group when you're going in is a much easier way to find stuff than like, gee, I wonder if they wrote a requirements draft for this and trying to dig it up. So it's just a matter of like getting the stuff in the face of newcomers, a new implementer, trying to understand why we did what we did, having it in a easier place to find, I think could be helpful. It's just my point. Stig?
Yeah, hi, Stig here. At least one possibility is that, if you have a requirements draft that has expired and, is basically dead, you can still, when you have a solution or some other document, have an informational reference to that.
Oh, that's
so
gotcha.
you can still have
so
a way
you
of
have
finding
informational
it.
reference to an expired doc.
Yeah.
Well, if that was adhered to as a policy in the drafts, I mean, then we kind of covered our tail there in the requirements. You can go find it, right?
Yeah.
That would be a helpful alternative to actually publishing it, but to ensure that the informational references are consistent.
Right. Another thing, I guess in general, once you do a solution, you could also have an appendix or something where you just put all the requirements, in the solution draft.
Interesting. Okay. Good feedback. Thank you very much. We got 2 hands up. Is that you, Jeffrey? I got you. All right. And Andrew, is that an old hand or the same hand?
Old hand. Put it down.
All right. Excellent. Thank you very much.
Okay, thank you.
So going back to the missing presentation here.
Hi.
Oh, we got audio. Awesome.
Yeah, I fixed it. Okay, it's very relevant to my topic today.
All right, you're live. Go.
Okay. Hello, everyone. It's Siyu from Huawei, and I'm on behalf of my co-author Fang Hong. And today I'm here to introduce you about my draft of the BIER Anycast MPLS label. So next slide, please. This draft mainly talks about a fast failure recovery method for BIER under certain network topology. As shown on the left side, there are several sites deployed from the sender side to the receiver side. In each site, 2 BFRs are deployed to perform failure protection. Each BFR can be backup device for the other one within the site. We'd like to design a method that can minimize reliance on unicast routing reconvergence after the failure, and we hope it can be compatible with existing BIER protocol and signals. We also hope this method can be friendly to existing hardware platform. Therefore, we proposed a failure protection mechanism using Anycast and bypass MPLS label. Different BFRs within one site share same Anycast label so that they can be combined as one entry in the upstream site BFR's BIFT table, while different bypass labels are utilized between BFRs within one site so they can forward BIER packets to each other. Next slide, please. Currently, when failure occurs at link between PE3 and PE5, the failure recovery procedure goes like this. IGP protocol firstly recalculate a new reachable next hop towards PE5, which is PE6. The IGP protocol will notify this result to BIER protocol, and BIER will update BIER routing table and then BIER forwarding table. During this procedure, control plan and data plan update happens when failure already causes packet loss. Next slide, please. We introduce Anycast and bypass label, and they work like this. So firstly, BGP and IGP protocol exchange their protocol messages between each BFRs. In particular, each BFR advertises the new BIER info TLV. The format is shown in the figure. There are bypass label and anycast MPLS label contained within the TLV. Anycast MPLS label should be distinct among sites. After B receives the BIER info TLV, it will generate a new format of BIFT table. Because BFER C and D share the same anycast label, their BFR ID will be combined together into one entry in the BIFT, and their anycast label will be recorded in the table as well. The anycast label will be used when BIER packet needs to be encapsulated on BFRB. Before link failure happens, the flow can be forwarded from B to D and finally to CE. Next slide, please. When link failure happens between B and D, the link failure can be notified to BIER and the original BIER neighbor D cannot be used anymore. So neighbor C will be automatically chosen and used for BIER forwarding. When BIER packet is forwarded from B to C, the anycast label 3 will be used to locate BIFT table. The destination bit 2 within the bit string will be used to look up the BIFT table. C will find out that neighbor D is the destination and it will forward BIER packet to D. In BIER header, bypass label 32 is encapsulated. Finally, D will forward the packet towards CE. During this procedure, no BIER packet will be dropped because the backup entry has been calculated in advance. Next slide, please. So there are several advantages of this method, such as that failure recovery is immediately performed. There is no additional BIER packet addition. BFR won't modify its existing behavior of packet encapsulation. Besides, the reliance on IGP reconvergence are minimized. The uniqueness of BFID and BFR prefix are not affected. Next slide, please. So here, we'd like to thank Jeffrey's review on this draft and hope my slides help you understand our new method. We will keep fulfill this method topology scenario and the remaining sections in the later version of this draft. And thank you. So that's all.
Comments? Okay, Jeffrey's got one.
Yeah, so I had posted some questions before, and thank you for answering those. But I have not got the chance to really understand the problem and the solution. And after hearing your presentation, my questions are still unanswered. I'm not saying that this does not work. I'm just saying that, at least from my side, I still need to digest this before I can have further comments. Thank you.
Okay.
Yeah, I just want to, this is Greg speaking individually. I agree in that the statement of minimizing reliance on IGP reconvergence, like what we have now is amazing, right? The fact that we used to have all this flow state, now it's just topology, IGP convergence, and the stuff we've seen with BIER following up is single-digit milliseconds. So I'm trying to, I agree. I'm trying to understand what is the problem we're really trying to resolve here. Is just another way to solve a problem, or is it really a significant improvement of the existing environment that we need a new solution?
Okay, so you mean the IGP convergence now is extremely fast and acceptable? Or you are agree with my solution that the IGP
I'm trying to understand the problem that's trying to be solved. The IGP reconvergence is a problem. It's not fast enough.
Yes.
Okay.
Okay.
Any other questions, comments? Yeah, Jeffrey.
So IGP convergence itself, if we purely just rely on the IGP convergence, it can be fast, or someone may still argue that it's not fast enough. But because BIER uses IGP, or BIER basically uses a routing underlay, so whatever routing underlay has for fast recovery, we can use it. So IGP can use, for example, LFT, loop-free, LFA, loop-free.
Oh, yeah, gotcha.
Algorithm. I forgot exactly what. Right. So whatever IGP or even BGP use there, we can just use it already. So the exact problem we're trying to solve here is still unclear to me. But again, as I said, I just need more time to digest before I can say that this is really not good or not.
All right. Thanks, Jeff.
Okay. So we discussed this, we just find this problem when we have some real scenario in the SD-WAN use cases, just like we proposed the network topology, and we hope this method can solve some failure when the BIER are deployed in those SD-WAN use cases. And about Jeffrey's question, whether we can use the IGP-based fast failover, I think, yes, we can use them, but we just propose a new direction of BIER protocol-based failure protection. Because we just add some anycast label, which is totally a BIER terms.
All right. You follow up on that? Here we are, eyes to the ground. So we have Gunter with notes. We have final chance. This is our last piece of content for today. Any general questions, comments? How about Andrew, you want to take the mic?
Yeah, I just wanted to say thanks to the chairs. It's been a pleasure working with you over my tenure as AD. You will be missed. I am now going to go and have a beer and enjoy my retirement as an AD. Hey, maybe I'll end up on the IAP. Just kidding. Yeah, and best of luck, Gunther. And thanks very much. It's been a pleasure.
Thank you, Andrew. Everyone give Andrew a big round of applause. I'd like to congratulate the BIER working group as a whole for just burning through AD after AD, and we just keep moving on. All right. Very good. No blue sheets because you've all used your app, correct? Look at that. How much easier is it? All right. Thank you very much. You guys have a great week and enjoy the weather. Speed. Architecturally, BIER allows us to write on top of everything. Like, so if your IGP is fine